Assalamualaikum. My name is Mirza Nafisah binti Pardi.
Hi, my name is Nur Anis Falisha binti Ma'uf Mu'ad.
Hola, my name is Rusharina Alia binti Rozaidi.
Bonjour, my name is Siti Nurshafia binti Makna Zaidin.
And hi, my name is Zaitu Azrila binti Munawir Haris.
Before that, I will explain a little bit about our topic, which is radio astronomy. What is radio astronomy? The study of radio wave emitted by objects in space. To really understand, radio waves are a type of electromagnetic radiation. Just like a visible light, they can be described by sine wave, which is a type of periodic waveform. Because radio waves have such long wavelengths, they can pass through obstacles like walls and even our atmosphere, which is why we use them to study objects in space. But how do we detect this radio wave? That's where radio telescopes come in. These are like giant satellites that can pick up radio waves from space. In fact, radio astronomy helps us to discover phenomena such as pulsars, quasars, radio galaxies, and the cosmic microwave background radiation.
Next, let's move to the fundamentals of radio astronomy. Firstly, radio telescope. Antenna. The primary component of a radio telescope, usually a large parabolic dish, collect radio wave and focus them into a receiver. Receiver. The device converts radio wave into electrical signal. It often includes a low noise amplifier to exchange weak signal. Lastly, signal processing. The signals are processed to filter out noise and to extract useful data. This involves converting analog signal to digital form and performing complex computation.
Observational technique. Interferometry. Multiple radio telescopes are used together to simulate a much larger antenna. This technique, known as Very Long Baseline Interferometry (VLBI), achieves higher resolution by combining signals from widely separated antennas. Single dish observation. It involves a single radio telescope dish. While it provides valuable data, its resolution is limited by the size of the dish. Spectroscopy. Analyzing the spectrum of radio waves to study the composition, temperature, and density and motion of celestial objects.
Next, I will explain about the uses of radio telescope. First is pulsars. Pulsars are rapidly rotating neutron stars that blast out parts of radiation at regular intervals ranging from seconds to milliseconds. Pulsars have been used to test aspects of Albert Einstein theory of general relativity, such as the universal force of gravity. Radio telescopes detect the regular parts of radio wave, allowing astronomers to study their properties and behavior. Pulsars are used to test the theory of general relativity and to prove the interstellar medium. Second is quasars. Quasars are the remarkably bright cores of active galaxies in the distant universe. They are an extreme form of what astronomers call active galactic nuclei, or AGN for short. What causes large amounts of matter to head toward a supermassive black hole and activate it as a quasar? One scenario is a galaxy merger, when two galaxies crash into one another. The disruption caused by their respective gravitational fields shift the direction of motion of giant clouds of molecular gas in those galaxies, causing them to fall toward the black hole. Radio telescopes observe the strong radio emissions from quasars, providing insight into the early universe and the nature of black holes.
Other than that, there is galaxies. Galaxies are sprawling systems of dust, gas, dark matter, and anywhere from 1 million to 1 trillion stars that are held together by a gravity. Said by Dr. Glowacki, by implementing different techniques for finding galaxies, which are used for other Meerkat surveys, we were able to detect all of these galaxies and reveal their gas content. By mapping the distribution of hydrogen, astronomers can study the structure and dynamics of galaxies, including their rotation curves and spiral arms. The last one is cosmic microwave background radiation. The CMB is the faint afterglow of the Big Bang, visible in the radio spectrum. The CMB is the farthest and the oldest light any telescope can detect. It is impossible to see further beyond the time of its release because then the universe was completely opaque. That means there is no light can go through it. The CMB takes astronomers as close as possible to the Big Bang and is currently one of the most promising ways we have of understanding the birth and evolution of the universe in which we live. The observation of the CMB provide critical information about the early universe, its composition, and its evolution.
Imagine you are a radio astronomer. What is the first celestial object you would like to study?
Cosmic microwave.
The answer is pulsars.
First celestial object that I would like to study is cosmic microwave.
I think it is galaxies.